There, it's Johnson Praise here once again, your captain on this educational voyage at Johnson Praise TV. Join me as we navigate through the intricate waters of INFS211, that is Introduction to Information Technology Past Questions Review. Together, we will chart a course to academic excellence. Okay, so please make sure you smash that notification bell to join our growing community and stay connected for more educative content. Please make sure you do that. And I want to also take this opportunity to thank you for your support. Okay, the subscriptions and everything, your advice and encouragement really means a lot to me. Yesterday I was able to reach 1,000 subscribers. So thank you all those of you who have subscribed, and those who haven't subscribed to, please make sure you add your subscription to it so we can continue to work together. So please, as you already know, I've already released a video on INFS past questions. That is, I've released 2 videos for the past 2 days. I released some last 2 days ago. I released one yesterday, and today is the 3rd part. But if everything works out together, I will release my final one. That is going to be the general one. So let's pray. If I have time, I'll do that. But these videos that I've released, if you watch all these 3 videos and you get even 80% in your exams, then I'll say I need to lash you. That is it. Do you get it? You need to really pay attention to everything we are doing, the questions, the answers. We've taken our time to go through the answers, solve them. So we've done a comprehensive review on the questions. So these are going to guide you, and that is how it is going to be. So please make sure you do that. And if you have not subscribed, as I said, hit that notification bell and then give us a follow. We won't spend much time, so let's go straight to the let's go straight forward, right? Let's go straight forward, straight to the point, right? Now, the first set of questions was 30 questions. The second one was 35. Today I've added additional 5 to it. So anytime I release, I make sure I add 5 questions to it. So today we are doing 40 questions, and these questions, this is the most difficult aspect of INFS. I decided to release this one today because it involves calculations. Like I said, it really entails some little calculations, which I'll take you through some of these calculations. The lecturer has already made it known that your exams is going to be what? Multiple choice questions, and it's going to also either multiple choice and then fill in, so short answers you put it. So if you have not really gone through all the slides, you find it difficult to answer some of them. So you read everything, and these questions I'm bringing a cut across all the sessions or the slides. So please make sure you take whatever we are doing serious, and also do your personal studies aside watching this video, so it can also help you understand the concept very well. Now let's start. Question 60. So we solve up to question 65. Yeah, we solved up to 65 yesterday, right? So we are continuing from 66. It says that the devices that accept data from outside the computer and transfer it into the CPU are called, I'm taking it again, the devices that accept data outside, data from outside the computer and transfer it to the CPU is called, the CPU is what we call central processing unit. So what is it? The answer is what? Output devices. Output devices actually accept data from outside the computer and transfer it into the central processing unit. So that is it. So the input devices accept data in a form that the computer can use and send the data to the processing unit, okay, or the central processing unit. So that is the answer. So question 66 is A. Let's move forward to question 67. The types of integrated the type of integrated circuit that consists of arithmetic unit, control unit, and some main store is called the type of integrated circuit that consists of an arithmetic unit, control unit, and some of the main store is called. So we have all the options here. So let's look at the answer. The answer is microprocessor. Why is it microprocessor? So it's microprocessor because microprocessor is a type of an integrated circuit that contains all the essential components of computers or computer central processing unit, that is the CPU, on a single chip. These components typically include an arithmetic logic unit, that is ALU, for performing mathematical and logical operations, a control unit for managing the execution of instruction, and some form of memory storage, that is the main store for the temporal data storage and retrieval. Together, these components enable the microprocessor to execute instruction, process data, and perform computations. Okay, so making it the core component of a computer system. So the answer is microprocessor. So when they can give it to you in a form of short answer, so when you get something like this, they ask you a question like this, that a type of an integrated circuit that consists of an arithmetic unit, a control unit, and some main store is called, and you answer it as what? Microprocessor. It can come in a form of a short answer, so you must keep the definition or the question well, so when you get it you can type it, or yeah, you are going to, if yeah, you are going to what, do it, it's going to be what, you are going to do it on site. Do you get it? So you sit in front of the lab, the PC, and do it. Do you get it? With what? Strict supervision, like the university's standard has always been. There's going to be a strict supervision, so you make sure you keep everything. If you understand it, then it will be what, very helpful. Yeah, let's move forward. um a visual display unit is an example of a visual display unit as is an example of a visual display unit is always a monitor, right? But we don't have monitor here. A monitor is what, an output device. So if you don't have a monitor and you have output device, you should choose what, an output device. So a visual display unit is known as what, a monitor. It's an output device because it presents information to the user in a visual form. Output devices produce data or information from from computer system for the user to view, hear, or interact with. In the case of a monitor, it displays text, images, videos, and other graphical content generated by computer's processing unit, allowing the user to perceive and interact with the output, right? So the answer is what, output device. It's an output device. Question 69. The primary device that the computer uses to store information is called the primary device. When you take a computer, there are so many storages, but there's one primary device that we use to store information, especially when your PC goes off. Do you get it? There's certain things, if you store it in that specific device, your data cannot be deleted. Do you get it? Is it RAM? Is it CPU? Is it monitor? Which of them? The answer here is hard drive. If your data or your information is on the hard drive, it becomes difficult for it to be deleted even when there's light off. So a hard drive is the main storage device in a computer, storing large amount of data like programs and files, even when the power is off. Unlike the temporary RAM, that is random access memory, which loses data when the computer shuts down. The hard drive retains information for the long time. It's essential for keeping important files safe and accessible over time. While it may not be as fast as RAM, it offers ample storage space and reliable data uh, persistence. Okay, in short, the hard drive serves as the computer's primary storage solution for both short-term and long-term data needs. So that is the answer. Let's move to question 70. The main categories of peripheral devices are, so we have input devices, output devices, processing devices, and then we have both A and C. So which one is the answer? I choose A and C. Why did I choose A and C? The A and C is what? The input devices and then processing devices. Let's look at the reason behind, or the rationale behind the reason why I choose my answer. Peripheral devices are hardware component connected to a computer, serving specific functions beyond the core processing tasks. The main categories of peripheral devices are input devices. So one of the categories of the peripheral devices are what? The input devices, such as keyboard, the mouse, and a scanner. And output devices such as what? Monitors, printers, and stuff. And then we have processing devices like CPU. And okay, so the CPU are not what? The CPU are not considered as peripheral devices, as they are integral to the functioning of the computer. All right, so let's see. The whole thing is that the peripheral devices, they are component, they are hardware component connected to the devices. And if we say hardware component, it is something you can what? You can touch. So input devices, we have input devices, output devices. Yes. So the answer is what? Both A and C. All right. So we have what? Input device and then the processing devices. So these are what? The other categories of peripheral devices. Let's look at the question 71. The kilobyte consists of kilobyte. When you talk of kilobyte, it consists of certain bytes, okay, or certain bytes you come together to constitute what? A kilobyte. So let's look at the number of bytes that forms a kilobyte. I have here, yes. So with this one, one byte is equal to 8 bits. 1 kilobyte is equal to 1224 bytes, right? So the answer says, the question says that 1 kilobyte is what? Consists of what? So it is 1024, right? 1024. That is 1024. So that is what? The answer. Question 72. The ASCII, that is the ASCII, okay, code. ASCII code for letters A is 97. What will be the binary value for the computer system using the ASCII how they call it, coding system, the ASCII coding system? Right, the ASCII coding system, it is something that we have to now calculate for these things, right? I will teach you how we can calculate for it. So the answer is what? Is 0110001. Why is it 011001? So the question, the it has given you the letter, the code, okay, the ASCII code, okay, the ASCII code, that is the ASCII code. ASCII code here is 97, right? So if you want to know if 97, if you want to know the exact number, you divide 97 by 2. So if you have calculator, you can put it. I don't have calculator. I'm giving you the process so you can calculate it yourself. 97 divided by 2. Let's say like 9 divided by 2 will be 90 divided by 2 will be 45, right? 7 divided by 2 will be that is 35. That is 3.5. So add 3.5 to 45, which will be what? That is 5 plus 3 will be 8, right? Yes, so it will be 48, 48. So when you divide 97 by 2, it will be what? It will be 48, 48. Okay, so that is 48. Remainder what? Remainder 1. So I'll write the 1. Now you divide 48 by 2. When you divide 48 by 2, it will be what? That will be 4. That will be 24, right? So 24, remainder what? 0. Remainder 0. Then you divide 24 by 2, which will be 12. 12 what? What will be the remainder? Remainder 0. Then you divide this 12 by 2. When you divide 12 by 2, it will give you what? 6. 6 will be what? Remainder. So you write 6 here, remainder 0, right? And when you divide 6 by 2 to give you 3, remainder what? 0. And then when you divide 3 by 2, it will be 1.5. Okay, 1.5. So that will be 1.5. Okay, that will be 1. Okay, remainder what? 1 rather. 1 remainder what? Remainder 1. And you can divide, when you divide 1 into 2, like you get it. So that is it. So after writing everything, now you start from what? The down. Okay, the down. So the remainder, you put all the remainder together. So the down, I had 1, I had 0, I had another 0, I had another 0, I had another 0, I had 1, I had 1, I had 0. So my answer here is what? So when I start from the front, that's why I had what? 0, 1, 1, 0, 0, 0, 0, 1. So that is the answer. I will take you. There was a place I was able to break it together. So with that one, you understand it better. So let's move forward. Question 72, 73, right? 73. It says that the ASCII code for the number 1 is 49. What will be the binary for the computer system using the ASCII coding system? With this one too, you are going to what? Use the same coding system. Okay, so I'm going to take you through this one. So the ASCII stands for what? American Standard Code for Information Interchange. American Standard Code for Information Interchange. So in the ASCII coding, the decimal value for 49 corresponds to what? The character 1. So when you take the character 1, the decimal code, which is what? 49, it corresponds with the character 1. So to represent this value in the binary, you would have to convert the binary into what? You have to convert 49 to binary, which will be what? Which will be 110001. So the binary value for the ASCII code for 49 is 11001. Let's look at the calculation. So with the calculation, this is how. So first of all, what you have to do is that you have to convert a decimal number to what? Binary. So you convert that decimal number to what? Binary. When you say decimal number, it's what? A complete number. So you have to convert it to what? Binary, right? So to calculate it, you have to what? We have to use the I'm using the successive division. Okay, the method I'm using is what? The successive division. So here we are going to divide the numbers by 2, like the way I did for the first one. So now let's go. Step 1, divide 49 by 2. So when you divide 49 by 2, the quotient will be what? 24. When you divide 49 by 2, you what? You have 24. Okay, and then there will be what? A remainder. So that will be what? Remainder what? 1. So you write that remainder 1. So at the end of the day, is a reminder that we need. It's not the breakdown. We need only the reminders. So when you write the remainder, and then you break it again, write the remainder. You break it, write the remainder. So when you are done, you start from what? You start counting from down to top. So you start writing from down to top. That is how you get it. So now we're breaking the 49 into 2. That will be what? 24. The remainder what? 1. Making what? 49. Let's go to step 2. Divide the quotient, which is 24, by 2, which will be what? 12. When you divide 24 by 2, it is 12. So 12, what will be the remainder? There won't be any remainder because it will be what? Equal 12. That is it. So you write 0. So remainder 0. Let's go to the step 3. Divide the quotient 12 by 2, which will be 6. Remainder 0. Okay, so you write what? Remainder 0. That one too, you've added the 0 to it. Now, step 4. Divide the quotient, that is 6, by what? 2. So when you divide it by 2, you have 3. So remainder what? 0. That one too, you write it. Then fifth step, you divide what? The quotient, which is 3 by 2, which will be 1. Remainder what? 1. So you get it. And then the last one. So divide the quotient by what? The quotient 1 by 2. So when you divide 1 by 2, the quotient will be what? Will be 0. Remainder what? 1. So at the end of the day, when you want to write, we are starting from down here. Okay? We are starting from down here, which will be what? Which will be 1. Is that not it? 1 remainder. That the remainder, we are writing all the remainders. So 1, another what? Another remainder at the top, 1. Let's go to the next remainder at the top there, 0. Let's go to the other remainder, 0. Okay, let's go to the remainder, that is 0. Let's go to the remainder here, 0. And then that is it. So at the end of the day, this is how you are going to write it. So when you put all together, so now let's write down the remainders from the bottom to the top. It will be what? 110001. So the binary representation for the decimal number 49 is what? It's 11001. So the answer, that is what? Our answer. Okay. All right, let's try our hands on this question. Let's try our hands on this question. Try your hands on this question. Okay, it use the same method. So the question says that please drop the answer, right? If you can follow the same process to calculate it on YouTube for me, I am okay. But if you can't do that, and you can do and write, get me the answer, do that, drop the answer under the comment section, or if you show working too, I'll be grateful. So click on the comment section and drop the answer for this one, that the question I'm about to give you. If the ASCII code for number 2 is 83, what will be the binary value for the computer system using the ASCII coding system? So drop the answers there and let's move forward. Question 74. Now, someone will say, hey, information studies in your calculation. So I shock you, right? Mathematics is everywhere. So you need to what? Even in this world, calculation is everywhere. If you're not calculative, someone will beat you. So you always have to be calculative. If you are dealing with somebody and you are not calculative, or the person will always take you for granted. So you have to be calculative and know where someone's action has gotten to. If you realize the person's action is pointing out to a betrayal, you rather what? Quit or exit on time. All right. So you have to be calculative in this world. If you are even crossing road and you are not calculative enough, a car will hit you. So you have to be calculative, knowing that this car is coming from the distance that the car is using, or the distance is what? Far from me. That is what? On my left hand side. On my right hand side, the other one is closer. So if I cross, I can miss. I'll be able to what? Miss the first one, but the second one will hit me. So you make sure that they are all at the place where even if you cross the road, no car will be able to what? Get to your side at that moment. So that you have to be calculative. So it is everywhere. So if you fear calculation, it is everywhere. You calculate. Even when you are cooking, you have to measure the quantum, okay, of salt you put in the soup before you be able to. If you are not calculative, do you get it? So that is the food for thought. Let's look at calculate. Please, I'm waiting for my answers. Drop it under the comment section. Right, let's go to it says that the new technology named LED is an abbreviation for what? So they said light emitting diode. We have what? Liquid crystal display. We have lesser emitting diodes, and we have low energy display. So which of them is the answer? Okay, so the answer is what? Light emitting diode. Okay, so those of you who did science, we did these things in science. Okay, light. So a light emitting diode, that is LED. LEDs are semiconductor devices that emit light when an electric current passes through them. They are used in various applications such as indicator light, digital display, and non-enlightened fixtures. LEDs are energy sufficient, durable, and capable of producing a wide range of colors. The abbreviation LED stands for emitting diode, right? Light emitting. So if I pronounce something earlier, forget about that, okay? It is what? Light emitting diodes. So that is it. Emitting is, yes, that is how you go to write it. So they can give it to you in a form of in a form of what? Filling. So light, and then the emitting is what? EMITTING, and diodes. So that is the diode is what? DIODES. Some of you have been complaining that sometimes your videos you don't really get a good quality. I'm using HD. Do you get it? So if you are watching and maybe it is the slides are not really showing well on your screen, check the your quality. Do you get it? Go to your settings and then check the how do you call it, the quality of your settings. You see, some of you can just put it on 240, some will put it on 380, but at least you should, if you are watching, you want to get quality videos, you should fix it around 360 or 720. If it is 1000, that one day you are going to get the highest quality. But if it is 144 and you expect to get quality videos on YouTube, you won't get it. That one, it's what reduces the quality of the video. So please check those things, because the videos I'm uploading, they are all quality videos. There's nothing like a blur video that I upload here. Let's move forward. Question 74 says that small computers that are not microcomputers are classified as what? Small computers that are not microcomputers are classified as what? They are classified as what? Mini computers. So historically, they are referred to as what? Class of computers that are smaller and less powerful than the mainframe computers, but larger and more capable than microcomputers. So the microcomputers were widely used in the 1996, okay, in the 1960s through the 1980s for various tasks such as specific computation, process control, and business application. They are typically referred as more processing power and memory than what? Microcomputers, but were still smaller and more affordable than the mainframe computers. Therefore, they occupied a middle ground in terms of what? Computing power and then size. Hence, the term is what? Microprocessor. Oh, sorry, mini computer. So with the mini computer, as I said, the answer is what? Mini computer. So when they ask you that small computers that are not microcomputers are classified as what? And you answer as what? Mini computer. All the options I'm giving to you, they can come in a form of filling, okay, or multiple choice. So pay attention. If they ask you without the options, you should know the answer. That is it. And question 76, which of the following will you require to hear? Okay, which of the following will you require to hear music on your computer? All the phone. So they've given you graphic card, sound card, network card, and modem. So it is sound card. The sound card is used what? it requires by users to what to hear whatever their computers to hear sounds from their computers. When they go to the recording studio, those of you who have been into music before, you know what I'm talking about. They have what a sound card that really help them produce what quality sounds. Okay, so if your sound card is good, it's likely you are going to have quality sound. But if your sound card is just bad, it is not of quality, then trust me, the sound you'll be producing will be like someone shouting in a how do you call it? Someone shouting in the roadside. You get it. You hear so many sound, different sound inside. So a sound card is essential for processing audio signals on a computer. It is responsible for converting digital audio signal into analog signal that can be played through speakers or headphones. Without the sound card, the computer wouldn't be able to produce sound output, thus making it impossible to hear or any other audio content. The other options listed, thus making it impossible to hear music. Okay, the other options listed, that is graphic cards, modem, and then network cards, are not directly related to producing audio output. So let's look at the question 77. What is the permanent memory built into your computer? Okay, so what is the permanent memory built into your computer called? What is the permanent memory built into your computer called? It is what? Read-only memory, that is ROM. So ROM is a permanent memory built into a computer, and it is called read-only memory, because it contains a data even when the computer is turned off, and it is what typically used to store firmware or system software that doesn't change frequently. Random access memory, that is the RAM, is a volatile memory and used for temporary storage during computer operation. But the ROM is the permanent one. Do you get it? So that is it, the answer. So ROM is a permanent memory, but RAM isn't a permanent memory. It's what? RAM is a temporary memory. You understand the differences now. Let's move forward. 78. A file might contain audience handout, speaker notes, and electronic slides. So how do we call it? We have text document, spreadsheet, we have database and presentation. So the answer is presentation. What I'm doing a presentation, and it contains what? Files, contain text, okay, and then I contain electronic slides. That is it. So it is a presentation. And now let's look at it. So it is presentation because a file containing audio handout, speaker notes, and electronic slide typically refers to what? Presentation file. Presentation files such as those created with software like Microsoft PowerPoint or Apple Notes often include slides for visual content, speaker notes, and for additional information. Also, handout for distribution to the audience. Let's go to question 79. The ASCII code for the character 75. Okay, the whole thing is that the ASCII code for the character dash is 75. So which of the code is approximately to 75? What will be the binary value for the computer system that uses the ASCII coding system? So what will be the answer? So follow the same step that I gave to you to calculate for this one, and let's confirm. 79, question 79. Calculate it using the method I gave to you. So you divide 75 by 2, then whether there will be reminder, you write it, the remainder. So you'll be writing it, you continue to divide until you get to 0. You get it? So divide and be writing the remainder. When you are done, you start from the last one that you wrote. If it is 1 that you had, you write 1 1 2 2, whatever that you get, then you continue just like that. So that will be, so when you convert it, the answer will be what? 0 1 0 0 1 0 1 1. So that is the answer. So we are moving forward. Question 80. The ASCII code for another number is 1. Okay, the ASCII code for the number 1 is 49. What will be the binary value for the computer system using the ASCII coding system? So this one, to answer them, use the same method. So with these ones like this, they may come in the form of field. So you must understand the calculation for what the ASCII coding system, and I've done the calculation. So if you skip it, go back and check how I did my calculation. Watch the full video, you understand everything. All right, let's move to question 80. So question 80 is what? State the number of values that can be represented by a single byte. So what number can represent a single byte? So let's look at it. So since byte has 8 bits, there are 28 or 255 different 256 different combination of ones. So the answer is what? Is 256. The question says that state the number of values that can be represented by a single byte. What will be the value for what? That value that can be represented by what? A byte. And when you read the whole thing, it says that since a byte has 8 bits, there are 28 or 256 different combinations of ones and then zeros. That, do you get it? So the value is what? 256. 256. So when they ask you, it may come in the form of field, so you put the 256 there. Be familiar, monitor the question and be familiar with it, so you know how you can answer them. 82. There is dash is one of the abbreviations of ICT that deals with the transmission of information signals. So when you talk of transmission of information signals, it is telecommunication. You look at the telecommunication, is a branch of ICT, or information communication and technology, right? That specifically deals with the transmission of information signal over various mediums such as wires, cables, radio frequencies, and capital fibers and optical fibers. It encompasses of technologies like telephone network, internet communication, wireless communication, and satellite communication. Therefore, yes, so among the options, you could see that the answer here is what? Telecommunication. And then let's move forward to what? Question 83. 83. Any data or instruction natural okay, so any data or instructions natural into memory or computer is considered as what? So any instruction that is what? Natural into the memory or the computer is what? It is what we call what? The input devices. The instructions that are natural into memory of what? A computer is called data or instructions. Natural into memory of what? A computer is considered as what? An input devices. The input devices is any device or an instruction, or it is what? A device, any device, right, and instructions that are entered into the memory of a computer. Once the collection of unprocessed text, numbers, images, and audios and videos in the memory, the computer interprets and executes instruction to the process and data into the information. So like I said, so the input is what? Is any data that Input is any data and instructions entered into the memory of a computer. Once 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 data is in a memory, the computer interprets, execute instruction into the process, and then the data into what? Formation. So that is the answer. So it's what? Input. Let's look at the question 84. So the code used in computing BCD stands for what? So BCD stands for what? We have a binary coded decimal, we have bitwise computation digit, we have base conversion data, we have block code description. So the answer is what? Binary coded decimal. Binary coded decimal. So let's look at it. In computing and electronic systems, binary code decimal, that is the BCD, is a class of binary encodings and so in computing and electronic system, the binary coded decimals is a class of what? Binary encodings of decimal numbers where each digit is represented by a fixed number of bits, usually 4 or 8. So that is what? The BCD. The BCD. So you pay attention. When they ask you this question, you know how you answer. 85. The large computers with a wide range of peripheral devices are called, so they are called what? We have mainframe computers, we have supercomputers, we have microcomputers, and then we have mini computers. So which of them? We saw what? The large computers with with wide range of what? Peripheral devices. They are classified as what? Mainframe computers. They are mainframe computers because the mainframe computers are very large and powerful computers that are designed to handle extensive data processing tasks and support numerous peripheral devices such as printers, storage devices, and then terminals. They are typically used by large organizations for critical applications like processing large volumes of transactions, managing database, and running complex calculations. Mainframes are known for their reliability, scalability, and high performance capabilities, making them suitable for enterprise level computing tasks. So that is it. Let's look at question 86. Okay, we are getting closer. 86. Okay, thin neck and then thick neck. Okay, so thin neck and thick neck are types of what? Which cable are we talking about? They are type of what? Coaxial cables. Okay, coaxial cables. So the thin net and then the thin net and thick net. Thin net and thick neck are what? Example of what? Coaxial, or they are types of what? Coaxial cables. So there are two types of what? Coaxial cables, that are thin net and thick net. Thin net and thick net. So when you see these things, they are coaxial cables. Okay, so with these videos like this, the way it is, if you are busy or whatever, you can be playing it over. As you continue to play, the options will stick in your mind. You get it, and the answers will also stick in your mind. So that's how it will work. It is. That's how it is. So if you are busy and you know I've really taken you through all the whole thing, so you can be playing it over and over as you get time. And when you get time and it's set on it already, you know the options to choose. Do you get it? It should, in case there's something similar, you are good to go. But if it comes, they twist it to, you will know the option to choose. Do you understand it? And also, a collection of connected computer systems are known as dash. So collection of what? Computer systems are known as what? Dash. So this is what? A computer network. So this, what we are talking about is what? A computer network or network. So a computer network is what? A group of interconnected nodes or computing devices that exchange data and resources with each other. So the answer is what? Network. So collection of connected computer systems are known as what? Networks. 88. Using the ASCII, how many bits are required for two characters? when we talk of two characters, you look at, so 1 bit represent what? In the ASCII, one character stands for what? 8 bit. So if you are using it for two characters, it's going to be 8 plus 8. Sorry, is what? It's one is H, right? So 8 plus 8. No, it wouldn't be like that. So let me see the calculation I did. One is 7 rather. One is 7. So please, what I said, I so in using ASCII, how many bits are required for two characters? So one character stands for what? 8 is 7, right? So 7 plus 7 will be what? 14. So in the ASCII, that is American standard code for international interchange. Each character is what? Represented by 7 bits. Therefore, for two characters, they are what? 14 bits are required. That is what? 7 for each character. So when you are storing things in on the ASCII coding, it is what? Two characters represent what? 14 bits. Let's move forward. 89. If 1 kilobyte of data is equivalent to 1024 bits, how many kilobytes make 200 and how many kilobytes make 2 megabytes? So if 1 kilobyte is equivalent to, that is 1024 bytes, how many kilobytes will represent a megabyte? So now, can you do the calculation? Calculate. I've chosen the answer is for 248 kilobyte, but can you tell me why it is 248 kilobyte? Drop the answer under the comment section. I'm waiting. When you drop it, I'll answer you. So please, what we are doing, it is practical. They may ask you for 4 megabytes or even 8 megabytes, but you must understand how we calculate. In case they twist it, you should know how you do it. That's why I'm taking you through the practical aspect, so you understand these things very well, right? So please do that and send it. Drop it under the comment section. Now let's do, now you are done, so I'm continuing. So to find how many kilobytes are in 2 megabytes, let's use the conversion factor. So the conversion factor is for converting megabyte to what? Kilobyte. So this is where you represent 1 megabyte to what? 1024 kilobyte. So that is what 1 megabyte is equivalent to what? 1024 kilobyte. So to go ahead, to have what? To calculate for and then the question says that you are calculating using what? 2 kilobytes, right? So we have 2 kilobytes. So this is how we do it. So it will be what? 2 megabyte times 1024. 2 megabyte times, that is 1024. Okay. So when you multiply 2 megabytes by what? 1024, or 2 times 1024 to give you 2048. 2048. So when you multiply 2 times 1024, it will give you 2048. So the answer here is what? Is 2048 kilobyte. Let's move forward. Question 90. We are doing a lot of calculations here, right? Question 90 consists of bound strands of clear glass fiber, each the thickness of what? Human hair. So question 90 says that consists of bound or strands of clear glass fiber, each the thickness of a human hair. So it is what? A fiber, optical fiber. It is optical fiber. So optical fiber consists of bound strands of clear glass fiber because these fibers are specifically designed to transmit light signal over long distance with minimal loss and distortion. So it is what? Optical fiber. That answer. So when you get question that say consists what? That consists of what? Bound strands of clear glass fiber. each the thickness of what human hair is optical fiber. 91. Transmission is based on radio signals of various frequencies. That is what wireless. So wireless is what based on radio signals of various frequencies. So the answer is what wireless. We have wireless, optical, Ethernet, and then coaxial. So it is what wireless. If it has to be what if it always have to do with what radio signals or frequencies, then it is wireless. The radio stations, they are wireless. The TV stations are wireless. Do you get it? And so wireless transmission relies on radio signals across different frequencies to transmit data or information without the need for physical wires or cables. So when you are connecting to radio station, you don't need to connect wire from Accra, from where you stay to this place where Peace FM is, okay? Or you connect it from here to Adum, just to what? To connect with what? A radio station there. Then the wires in the world, every place that you pass, there will be what? Wires. So that what they are wireless. In question 92 says that what is the ASCII code for the binary code 0101 10001? So what is the binary code for 0101 0001? Yeah, so the zeros are 3 before the 1. So what will be the binary code? What will be the AC? What is what the ASCII code for that binary number, right? So let's look at, we here they have given you the binary number, so you must now look for the ASCII code. And there are sometimes they will take the ASCII code and they will give you the binary number. So whichever way that they give to you, you must learn how to calculate it. So with this one, you look at it. So the ASCII encoding, each character is represented by what? A unique 7-bit binary number. Okay, so the ASCII encoding, each character is represented by what? A unique 7-bit binary number. So the binary number 001010001 corresponds to the decimal value of what? 81 when converted to the ASCII, which is what? 81, and it represents what? The letter Q. So that is it. With this one, when you pick number 81 and you convert it, this is the number you are going to get. That is what? That is what 01010001. So that is it. Let's look at the question 93. 93 says that what is the ASCII code for the number 1? Okay, for the number 1, right? So we are coming to look at the code for the number 1. So the ASCII code for the character 1 is 49 in decimal. So which corresponds to what? 00110001. So in binary, it is what? The option is what we have what? Underlined. That is what the answer is what? 49. So forget about the underlined test, the highlighted test. The answer is what? The answer is what? 49. It's 49 because they have given you the figures already. Okay, the number 1 represents what? 49. Okay, so that is it. Let's look at 94. What is the capacity of your hard drive measured in? So most of these hard drives are measured in what? Gigabyte. So they give you a hard drive may contain like 20 gig, 100 gig, and so on and so forth. Let's say 64 gig. Do you get it? So they are measured in what? Gigabyte. And then which of the following is not an input device. When you talk of input device, we have monitor, keyboard, mouse, and printer. When you talk of something being input device, there are things with the input devices. Okay, they are let me explain the output device so you understand. When I take a speaker like this, speaker gives feedback. It gives something out. Okay, when you play, you hear sound out. TV, when you on TV or your monitor, it shows the screen of it. So they are what output devices. But with the input devices, they are rather the keyboard, those that you use to operate the computers. Okay, you used to give instructions. They are the computer, the keyboard, they are the mouse, the printers. They are what the input devices. But monitor gives information. Okay, we don't use monitor to perform or actually what monitors, you don't use it to perform a function. They give information. That's what I can say. They give information out. And question 96, the ASCII code for the character 75 will be the binary okay, it's what? So let me read the question again. The question 96, the ASCII code for the character dash is 75. What will be the binary value for the computer system that uses ASCII coding system? So this one, we have calculated this before. It's a try question. Calculate this and drop the answer. Using the same method, you divide it into 2 and then you write the reminders until you get to the down. You then put all the reminders together. That is it. If you have no, if you did not really follow the first thing I did, go back and watch the full video. You understand how you can calculate. So this is 96 is a try question. All of you should drop it and let me see if you understand the concept well. So the options here are here. I've given you the numbers, but your calculation should determine whether you understand it or not. Let's look at 97. The number of bits in EBCDIC, that is IBDIC. Okay, IBDIC. Okay, IBDIC code for computing is. So we are looking at what the number of bits in the EBCDIC. Okay, code. So we are looking at it. So the code there is what? So in the extended, so when you talk of the EBCDIC is what? Extended binary coded decimal interchange code. It's typically encoded using 8 bits, right? So similar to the ASCII, each number in the EBCDIC is represented by an 8 binary number code, allowing the total of what? 256 possible number. So this coding scheme was what commonly used in the older IBM mainframe computer and still used in some legacy environment today. So the answer here is what? Is the answer is what? Is 8. It says 8 bits, right? Yes. Let's look at the okay, so that would be okay. So this means that the two are together, right? So when you put the two together, 8 plus 8 will be 16, right? That is it. Okay, so let's move forward. Okay, so sorry, there was some confusion. The answer, I forgot to change the answer, so I highlighted the 16 bit, but the answer is what? 8 bit, because with the explanation it says it, or it's calculations, and if you are not careful, so pardon me for my earlier submission. The answer is what? 8 bit, because I've explained that it's what the the extended binary coded decimal interchange code is encoded using what, 8 bits. So that is it. Let's look at 98. The capacity of your hard drive is measured in this one too. We've answered it. Which one is the answer? Number 98. Drop the answer. If it is 90, if it is megabyte, say 98 is equal to megabyte, or 98. Number 98 is what? Is terabyte. Number 98 is petabyte, and so on and so forth. That is it. Let's now move forward. Question 99. The large component with a wide range of peripheral devices are classified as, with this one too, we answered it. It's what? Mainframe computers. Question 100. Thinnet and thicknet are examples of which cable? So it is what? Coaxial cable. But mostly when you're answering fill-in questions, look at the back, right? Okay, the last one. If it already it is coaxial cable, but they have given you the cable, so you don't need to write cable again. So always when you're writing fill-ins, make sure you pay attention to these things. That's why sometimes you do fill-ins and you get all wrong, because you don't pay attention to some of these things. So the cable, you don't have to write the cable again because it has been given. So only write what? Coaxial. Let's look at question 101. Collection of connected computer system is known as what? A collection of connected computer systems are known as what? Networks, okay? Or it is known as network. Okay, and then let's look at how many bits does the computer need to store the word man. Okay, so how many bits does the computer need to store the word man? Please, how many words? The answer is 24, but can someone explain to me why it is 24? Can you explain to me why it is 24? Right, let me explain to you. Already you know that 1 bit, okay, represents what? 7. Okay, it is what? 7. 1 word stand represents what? 7 bits. Okay, so 7 times 3 will be what? Can someone tell me? 40 plus 7. Let me look at it. Oh, it's 8 bits rather, right? It is 8 bits. So what? 8 plus 8 is what? 16. 16 plus 8 will be what? 24. So to store the word man in a computer, it typically requires a total number of 24 bits. Each character in the word man will be represented by using 8 bits. So that is what? 8 bits represent 1 word, right? And it since the ASCII coding scheme is commonly used in computers, therefore 8 bits are needed for what? 8 bits are needed for the word M. 8 bit is also needed for the word A, and then 8 bit is also needed for the word N, which will be equivalent to what? 24 bits. So that is it. So in when they say, okay, now let me give you another one, then you calculate for me. How many bits does the computer need to store the word Johnson? So Johnson is what? 7 words. So how many bits does the computer need to store the word Johnson? Okay, so type it. Get me the answer. Okay, before I get to an end, let me take this opportunity to express or tell you an interesting opportunity. Okay, the interesting opportunity is that there are some offers, that is some job offers and traveling offers in countries like US, UK, Canada, Mongolia, this country Serbia, Dubai, and then I have Poland and then Singapore. So these are the countries I have offers in these countries. So if you want to travel to any of these countries for work, we have works there that as soon as you get there, you are going to be employed, right? So we work on your documentation. So get in touch with me. Call me on 0545 41 2017. And those that want to study in Canada and USA to call me on 0545 41 2017 and I will attend to you. And just yesterday too, I reached 1,000 subscribers. God bless you all for your support. I really cherish your support. Okay, thank you for subscribing and keep on supporting me this way, the way you share my videos and everything. I'm really grateful. Let's move forward. Question 103, that's 103, says that what character does the binary code 1001001 represent in the ASCII coding scheme? So with this one, let me show you the, so with it says what character does the binary need? So we have what options are Q, R, Q, P, R and S. So it says what the character that it needs to store the binary, which is what 0 0 1 0 1 0 0 1. Okay, 0 1 0 1 0 0 1. So let's look at here. The first one is 0 1 0 0 0. So it is ruled out. The second one is 0 1 0 1 0 0. So Q, that is the option. So Q is the answer. So what is it? What character does the binary 0 1? So pay attention. This one is character. The previous ones didn't say character. The ones I asked you to calculate, they didn't say character, right? This one is say what code does the character. Do you understand it? So pay attention to the differences. So you don't go and write a character in place of a code and a code in place of a character. Pay attention. So when they ask you to write a character, you know that the one you have to provide. When they say you should write a code, you should know what you have to provide. So this one, it says what character does the binary number need? So the character is what? The characters are Q, P, R, and then S. So if you don't even know, at least write some of them. At least Q, P, so that is it. So look at it. When you take the characters, we have what? A, we have Q. Do you get it? We have plus, we have 9 and this. So these are the characters we have. So it is what? It is Q. At least if it is not Q, it may be A, because these are the characters we have. If it is not Q, it may be A. Let's look at the or plus or 0 or 9. Let's look at the question 104. The information processing cycle. In the information processing cycle, dash is regarded as the building block of information. So let's look at here. It says that data processing cycle. Data is the building block for information. So data, the answer is what? Data. The last one says that the dash unit of the computer fetches data from memory for processing. So that is what? Central processing unit. So central processing unit is responsible for fetching instructions and data from the memory for processing. It contains controls circuitry that coordinates the fetching of what? Instruction and data from the RAM or the storage device. So the CPU then execute this instruction using arithmetic logic unit and other processing components. So that is the whole thing. God bless you. Please make sure you subscribe and share the video for me. If God willing and there's time, I will bring you maybe the final one before your examination, but that is what I have. But please, with these videos, make sure you watch all the 3 videos I've uploaded. The first 3 videos on information past questions review, that is the title. Okay, INFS211 past questions review. When you search, you will get those videos and then you watch them, you share them. At least when you go through this, I'm not sure you go and sit in the exams without even knowing what to do. God bless you all. A Johnson praise and be expecting more.